this video, we're going to find the speed, or rather the angular velocity or angular speed, which this mass is going to have when rotating after following this displacement or after following this distance, and the time it will take to drop from the initial position until it covers this distance. So make sure you subscribe and also turn on the notification bell so that you can get notified every time I post a video. So let us proceed as follows. In order for us to figure out questions of this kind, the first thing that we need to do is we need to come up with this. So for M1, okay, so we are going to come up with the, we're going to resolve this one and this one, or rather we are going to work out with this and this, then we combine them. So we have for M1 we have this one, where we have this one as M1G, and since it is going up, since this is coming down, so the direction will be, this one will be going up, so we have the tension here. And we know that summation of forces in Y must give us MA in Y. So we have T minus M1G must be equal to M1A. So let's call this as equation number 1. For M2, so we have for M2, M2G. And since it is coming down, we are going to, so this is T, we are going to say M2G minus T. This must give us M2A. So this one, since it is coming in this direction, this will be positive, this will be negative. So let us call this as equation number 2. From this point, let us add equations 1 and 2. So we have T minus M1G. Then on the left, so also from 2 we have plus M2G minus T, which must give us M1A plus M2A from the right. So from this we can see that this is positive, this is negative, so this will cancel. And what we're going to have is, so since this is positive, this is negative, we're going to have M2G minus M1G will give us M1A plus M2A. From this, we can make A the subject of the formula. So we have M2G minus M1G is equal to A. Since it is the common, we have M1 plus M2. So that if we divide, we have M1 plus M2. So that A will be, if we want from this, we can also factor out G. Okay, let's factor out G. M2 minus M1 over M1 plus M2. So let us call this as equation 3. So now putting equation 3 into any of the equations, into either equation 1 or equation 2, we have, okay, from equation 1 we have T minus M1G is equal to M1A. So we'll make it the subject. We have T is equal to M1A plus M1G. So if we put this in this, we're going to have M1. What is A? We put G. M2 minus M1 over M1 plus M2 plus M1G. So from this point, we can distribute this M1, M2G minus M1, M1G, everything over M1 plus M2 plus M1G. So over 1, so that we work it out from here. So the common denominator here is M1, M2. Listen to this, we just have M1, M2G minus M1, M1G. Then this one into this one, M1, M2G minus M1, M1G plus. So this one we have M1, M1G, then plus M1, M2G, everything over M1 plus M2 plus M2. So we know that this one is negative and this one is positive. So this and this we will go, and what we're going to have is M1, M2G and M1, M2G. So this we're going to get 2 M1, M2G over M1 plus M2. Tension. Putting in the values of T is equal to 2 times M1, 0.5 times M2, 1 times 9.8 over 0.5 plus 1. So this one is going to give us 6.5 newtons as the value for tension. Now, from this, having solved this, we know that torque is equal to I alpha. And again, we know that torque is equal to TR. So let's call this as asterisk 1, this one asterisk 2. So asterisk 1 and asterisk 2 are equal. So we have I alpha is equal to TR. So that we divide by I and also here by I. The goal is to find the angular speed. By angular speed, in order for us to find that one, we need this one, we need the tension and everything so that we come up with that one. So that this and this will go, we're going to have this one is equal to TR over I. So we can plug in the values. T is 6.5, then R from the data here it is 0.08, then I is 0.008. So this one on punch on a calculator we're going to get 65 radians per second squared as the value for this. Now, having solved this, we know that omega squared is equal to initial squared plus 2 alpha theta. This one, since it is coming from rest, this is 0. This one is a constant, we have it. This one we have. Then we are remaining with this one. But the relationship that is between linear displacement and the angular displacement is S is equal to R theta. So theta is equal to S over R. So the displacement that is going to cover, it is 3. Theta is equal to 37.5 radians. So putting in this equation, we have 0 plus 2 times 65 times 37.5. Introducing square root to both sides. Here we are going to have 69.8 radians per second, which can be rounded off to 70 radians per second. So this is the speed, the angular speed or the angular velocity. Then for part B, for how long, we know that it is about time. And one of the equations we have, this one is equal to ut plus half at squared. X is equal to, since this is 0, it is a t squared. So that 2x is equal to a t squared over a. We have t squared is equal to 2x over a. But a is equal to r alpha, angular acceleration times r. So this we have 2 times 3 over 0.008. 0.08 times 65. So punching this on a calculator and figuring out everything, we are going to get 1 second at the time.